Hello, this is Mr. Flatness, and today's lesson focuses on powers and exponents. The first slide has some important vocabulary that you need to write down in your notes, so if you'd press pause and write down all the terms plus their definitions so that you can use them at a future date. These terms you should also be studying on a nightly basis so that you can memorize them for upcoming quizzes and tests. So we have a power, and a power is just a way of writing repeated multiplication. So 10 to the fourth is a smaller way to write the same thing, which would be 10 times 10 times 10 times 10. The base that we have is the factor, the number that you keep multiplying would be another way to think about it. Also the number used as the factor. So 10 is my base. You can also think of B base, B bottom. The exponent is how many times you're going to multiply the factor. So this 4 right here tells me I'm going to multiply this 10 4 different times. So 10 to the fourth power, we said, is 10 times 10 times 10 times 10, which is the same thing as 10,000. Notice I see 4 zeros, 1, 2, 3, 4, and I have 4 zeros in my answer. Another skill that you need to do is be able to take a look at a power such as this and say it. So here my base is 4 and my exponent is 2, so I would say this as 4 to the second power. I could also say this as 4 squared. In the next example, we have 5 as the base and 3 as the exponent. So in order to say it, we would say 5 to the third power, or we could say 5 cubed. So we need to be able to look at them and be able to say what they are. We also need to be able to solve them. So to solve them, we have two more examples right here. Notice I have replaced some numbers now, or the bases, with actual variables. And then notice up here that I have assigned the variable a number. So in example A, I have y to the fourth power. So notice up here y is 2. So in order to evaluate this, I would simply plug in 2 for where y is and then put that to the fourth power. And to solve for that, evaluate it, that means I need to take the base, which is 2, and multiply it 4 times. So 2 times 2 times 2 times 2 would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So therefore, to evaluate 2 to the fourth power, we would say the value of that is 16. In the second example, B, we have x to the third power, or x cubed. So notice here above, x is 3. So what I'm going to do is plug in 3 for x, so that would be 3 to the third power. And to solve that, I would multiply 3, the base, 3 different times, and come up with my answer. 3 times 3 would give me 9, 9 times 3 would give me 27. So 3 to the third power is the same thing as 27. The final thing to look at when working with today's problems is looking at an example where I have repeated multiplication and then in turn write that as the shortened power. So notice I have the letter M, and notice I have 4 of them. So the repeated multiplier would be your base, so my base is going to be M, and then because I have 4 of them, it would be M to the fourth power. In my next example, notice now I just have a whole number. And so now I need to change my thinking a little bit. I need to write this whole number 25 in a format where I have a base and an exponent. So I need to be thinking about, well, what number can I multiply by itself to get 25? Well, now basic facts tell me I know that 5 times 5 is 25. So there's my repeated multiplication. So now I can write the power based on this multiplication, because I know that 5 times 5 would be 5 to the second power if I were to write the exponent. So you'll see all these different formats throughout what you're going to be doing in your homework tonight. In our next examples, we want to take the numbers that we have and we want to write them as a product of the same factor, and then we want to find the value. So taking a look at 5 to the third power, I'm going to rewrite that as repeated multiplication, 5 times 5 times 5. So that's the first part, that's the product of the same factor. And then to evaluate it or find the value, 5 times 5 times 5 would be 125. So here would be a two-step problem where I need to show both steps. Press pause and solve B on your own, then press play to see its solution. 4 squared should be 4 times 4, and 4 times 4 would give you 16. Another concept that I'd like to talk about involves perfect squares. So the word in and of itself, when you think about perfect squares, in your mind you should be thinking about a geometrical shape. You should be thinking about a square. So looking at the square, I'm trying to draw one here. It's not allowing me to do that. So we'll just draw one with a pen. When I think about a perfect square, what do we know about perfect squares? All sides are the same. Okay? So when you think about it, this square could be a 1 by 1. I could also make another square that's double in size. Make it a 2 by 2. So if it's 2 by 2, how many little squares do I have in it? Well, you'll count, and I have 1, 2, 3. I have 4 squares inside there. So when we talk about perfect squares as geometrical shapes, we're drawing shapes. But when we talk about perfect squares when we're dealing with numbers, the numbers 4 and 9 and 16 are called perfect squares because I can make a square where I know that if I have 4 squares in it, I know that that's a 2 by 2. If I want a perfect square that has 9 little squares in it, now I'm going to make it a 3 by 3. And 16 would be obviously a 4 by 4. And my art isn't the greatest, so I know that they're not perfectly little squares in there, but you get the concept. So that's why you call these numbers like 4, 9, 16, we call those perfect squares. So let's talk about that with more numbers. So we've listed the first few perfect squares. We've talked about the number 4 as a perfect square. We've talked about next one is 9, which is a 3 by 3 square. We said a 4 by 4 square then would be what? 16. I forgot about 1. A 1 by 1 is a 1. So now let's continue on. So there's the first 4. 1, 4, 9, 16. The next square, let's see if you can come up with the next 3 perfect squares. Press pause and I'll let you do that and then I'll solve them for you once you press play. So this 16 was a 4 by 4 square. So the next one would be a 5 by 5 or 25. That's a 5 by 5 square. The next perfect square would be a 6 by 6 or 36. And the next perfect square would be a 7 by 7, which is a 49. So these numbers, 1, 4, 9, 16, 25, 36, and 49, those numbers are all called perfect squares because I can split them up into dimensions that make perfect squares. And the next question, is 1 a perfect square? Yes, it is, because the smallest square I can build is a 1 by 1, and 1 times 1 would be 1 square in the middle. Please write these down in your notes, as you will again need to know what perfect squares are and how to utilize them. So we've talked about perfect squares in the previous slide. Well, now we can talk about what square roots are. And the square roots are simply the factors multiplied to get the perfect square. So in the previous slide we talked about the number 16, and what kind of square would you have to build in order to get 16 little squares in the middle? Well, you would need to build a 4 by 4 square. So the square root of 16 would be 4. Okay? And how do we show that as far as symbolic notation? We need to use what's called a radical sign to show you and to show everyone that we're talking about square roots. A radical sign looks like this. Looks like a check mark division combination symbol. And so if I were to write this is called a radical sign. You're going to want to put that in your notes. So if I wanted to write down what is the square root of a particular number, I would do this. What is the square root of 25? Is what I'm asking right now with that symbolic notation. Well, again, I would look at what are the dimensions of a square that would give me 25 squares in the middle, and that would be a 5 by 5. So the square root of 25 would be 5. In our final slide, here's a few examples. So what we'll do is find the square roots of these numbers. I'll do the first one. You can then press pause, and then you can figure out the square roots of the remaining 3. So if I want to find the square root of 36, here's how I would write it symbolically. Radical sign and then the 36 inside the radical sign. The square root of 36 would be 6. 6 by 6 gets you 36. So press pause now and give me the 3 square roots in the next 3 numbers. Square root of 81, you should have come up with 9. The square root of 64, you should have come up with 8. And finally, the square root of 121, that would be 11. So now you know, and we've talked about powers and exponents, we've talked about perfect squares, and then their opposites, which are square roots. This concludes the lesson on powers and exponents.